Hello and welcome. I hope you're caffeinated. Um, so, uh, Throughout this day, we've seen a lot of examples of where we need to use TEs, one of them being a fantastic talk by folks from Signal, where they emphasized how much effort they've put into making things end-to-end secure. One of the sort of weakest links in such security is your mobile phone. So if you take examples of secure messaging apps such as Signal and WhatsApp, although they invest a lot of time in cryptography and side channel defenses and enclaves, at the end of the day, the user is going to use this app on the phone. And there are several threats to this app, most particularly malware, bad apps that you can install on your phone or be tricked into installing. Permission abuse, so you see all these prompts and there might be attacks which trick you into giving permissions to apps. And security vulnerabilities. There is so much software on your phone, any mistake and the data from your chat app can be leaked to unintentional parties. The good news is that there are a lot of important initiatives to fix this, most important being the ones by your operating system provider, the two big companies being Apple and Google, so Android and iOS. They have large teams of security experts. They, for example, curate the app stores to make sure that malware apps do not get onto the stores. They use cutting-edge technology, so everything from enclaves and so on, to protect the applications and the operating system, and they do a pretty good job of giving you very nice user interactions and performance on all sorts of hardware. Okay, so looks like problems are solved. Why am I here? Well, there is a bad news. First, operating systems can abuse the power we give them. There have been some infamous examples where, oops, we tracked you, and this is not just one company, multiple companies kind of end up doing this. Another example being if they control the app store, they can also control which apps get on there and get financial benefits from this, the most infamous example being the Fortnite legal case. Now, these might not be that worrisome examples, but one of the most critical ones has been during the pandemic, and this came up in the talks in the morning as well, when folks were building contact tracing apps. They had to go and pledge to Android and Apple to give them access to Bluetooth beacons, and this was really difficult. We had sorted out everything else, and this was the last piece, which made it difficult to launch contact tracing apps. Okay, so now you might say, hey, if you don't like Apple and Google so much, why don't you ask users to switch to a completely different ecosystem? And there are plenty of them out in the market. A lot of nice Linux-based phones, Graphene OS, which is also very popular with security enthusiasts. But imagine a normal average user being forced to switch to these systems overnight. This is very difficult. And you're asking the user to make a choice. Either stick with the nice and amazing ecosystem you have and give up all your freedom, or switch to one of these Linux phones and good luck launching a terminal and playing videos on your phone, right? Ideally, what we would want is to have sovereignty on the phones that you have today, right? So I should be able to enjoy the good user experience that I'm used to while being able to control what I can run on my phone without being held hostage by operating systems. Now, although I have been motivating this from a user's perspective, for example, who wants to run a chat app, if you have such sovereignty, there are a lot of other stakeholders that can benefit from this. One of the most surprising ones being the operating system itself. If you can isolate applications from operating systems, then Android will be relieved that if there are malicious apps, they will not be able to attack the operating system. So this is beneficial for the operating systems themselves. And lastly, the manufacturer would also be open to this idea, because the manufacturers also have a lot of security sensitive applications that they run on your phone, and they would really like to protect themselves from all the other software on the platform. Right? So now this sounds very much like, like a pitch for trusted execution environments. You want to protect data in use. Why don't you just use TEEs? Well, people have tried that. And this is how, if you're not aware, this is how your current mobile phone stack looks like. It's crowded, it's complicated. There are not one, not two, but 3 hypervisors running in there. There is a hardware isolation mechanism called trust zone, which lets you create 2 worlds. There is a secure operating system. There are different drivers. It's really, really, really crowded. And even after that, it doesn't achieve what we want for 2 main reasons. All the hypervisors that you see here are either written by the operating system itself. So Google now provides you a hypervisor. So if they want to do the control that they're doing, they can now just do it at a hypervisor level. They still get to see all the code and data that you're executing. So it doesn't give you the guarantees you want. And looking at the TEE examples, one big problem with the TEs on ARM platforms, at least on your phones, is the TEEs get to access everything, including the operating system's code and data. Right? So Android is not comfortable with these secure operating systems accessing their code and data. Okay, so how do we solve this problem? This is where I introduce you to TEEtime, our solution. And there are a few interesting things we do. The first one being we want to maintain compatibility with existing ecosystems, right? So for example, you still get to run Android, you still get to run your Netflix app or whatever your favorite app is, and we call that the legacy domain, right? And what we allow you as users to do is we allow you to launch something called as a sovereign domain. Now the nice thing about sovereign domains is you can still run your existing apps. You get to choose which runtime you want to execute. You can choose Linux, you can choose Android, it's up to you. But there are 2 important parts if you notice. One is there is no hypervisor, right? So if you don't have a hypervisor, you don't have to trust it. If you want one, you can put it in there, but the user will not have to trust it, the sovereign domain will not have to trust it. The other one that you see here is the peripherals are now being separated into 2 domains, right? So suddenly your Bluetooth, your display, and your storage has been moved to the sovereign domain. And this is necessary. Unlike on server DEs on your phones, there is a real user who's going to interact with it. So if you're chatting, the user needs to see things on display. He needs access to network and storage and so on, right? Now, how do we do this? Well, nice thing is this is simple and pragmatic, compatible with hardware, compatible with software. It does not disrupt any of the usage scenarios. Let's see, transition, yes. Hypervisors are not in TCB. The only change we do is to the firmware. The firmware is provided to you by the manufacturer who gives you hardware. So in terms of trust, it's as good as it gets. And lastly, I will now explain also how do we achieve this ability to attach and detach peripherals directly to domains. Now remember, you don't have a hypervisor to virtualize things, and this is what makes the problem challenging. Okay, so the first sort of setup that I'm going to talk about is, imagine going back to our example of a chat app. We would like to run the chat app in our sovereign domain. It needs a certain number of resources, so time and memory being the obvious ones, and the 3 peripherals that we talked about. Everything else, including scheduling, memory management, access to other peripherals, can stay in the legacy domain if need be. Okay, so with this setup, how do we achieve the isolation? So the first is, how do you isolate time and memory? This has been done quite a lot, and this is not new. There are 2 ways we can do this. On your phone, you have multiple cores, so you can decide on one core, I'll run one domain, on another core, I'll run the other domain, and make sure they don't interact with each other, right? So this is isolation in space. Similarly, you can do isolation in time. You can pause the other domain, just run one of these, and then switch back, right? And we also allow a nice combination of these. Similarly, for memory, you do the same thing. You isolate the memory regions, and using existing hardware isolation mechanisms, you can decide which domain gets to access which memory, and if they try to access each other's memory, the hardware stops you from doing that. And this again works in space and time. People have done this on different platforms, and there is nothing new here. The new part in TEEtime is the peripheral aspects, right? So as I said, how do you attach and detach peripherals? How do you even know which domain needs which peripherals? What happens if they want to share? What happens if I want to use my chat app? Well, first, the thing that we do is we take the application, let's say your Android APK, and it already tells you what permissions the app needs. So we kind of can use that as a manifest to decide which peripherals your app needs access to. Now, if you give all the peripherals to your chat app, then everything else will stop functioning on your Android. Right? So the nice thing we do is for resources such as your touch screen, which includes display and input and output, we allow the touch screen to be exclusively assigned to the sovereign domain, right? So when you're running your chat application and interacting with it, your Android runs as if it does not have a touch screen, and it's fine. Nothing bad happens. For peripherals such as storage and network, you can do something interesting. For example, you can use secure channel, you can encrypt and integrity protect your data, and then send it to the SD card or over the network. So you can proxy accesses, right? You can still keep these peripherals in the legacy domain and allow the chat app to operate over it. How do you isolate peripherals? Well, the nice thing is peripherals are also mapped into memory, so we can use the same spatial isolation along with memory. You now also isolate the touch screen, both in space and in time. Okay. All right. And again, you can combine these things together depending on which peripherals and where they are mapped. So far, so good. Looks like the memory isolation principle is consistently being applied to execution, memory, and peripherals. Well, the fun part is interrupts. So if you look at these peripherals, they're highly interactive, right? Whenever a state changes, the peripheral sends an interrupt to your course. And in fact, on ARM, there is a dedicated piece of hardware called the GIC or the GIC, which manages all of these interrupts. And now suddenly, because we are dividing peripherals into two of these domains, all of their interrupts have to be securely configured, handled, routed, and so on. And this is where all the nice systems and security challenges show up. I will spare you the details, and I will not bore you with how we do it, but that's if you're interested, you can take a look at our paper. The long story short is that we have to ensure the configurations are isolated, and when the hardware interrupts are fired, they're routed correctly to the right domain. So putting it together, how does this look like as a user? If you're telling me this runs on a phone, explain to me how it runs on a phone, right? So the way this works for the user is that whenever the user wants to launch their chat app, they simply press a physical button on the phone, which switches your phone's touchscreen to go to the sovereign domain. Behind the scenes, the legacy operating system or the Android operating system loads your binary and allocates resources to it. And once that's done, the hardware starts the isolation, takes over the resources, and your application then starts running on one of the cores, nice and clean. Operating system cannot attack it. Right? Once you're done interacting with your chat app, the user can push a button again, and the resources go back to the legacy domain, and then it can take over the screen again. Right? Now we are building this. We are pretty serious about building this. We have multiple implementations. One of them is on an ARM emulator, and then we have several phones and development boards on which we are trying to run this to make this a reality. And when it comes to usability and time, in terms of performance, the costs you have to pay are one time. When you boot up your phone, it will take twice the amount of time. But during execution, the switching is seamless and fast. Okay, so I will end my talk with a nice demo on how this looks like. So here we go. All right. So we start with a user using a browser in the legacy OS. Now they want to open a chat app. They press a physical button on the phone. It switches to the sovereign world, a new fresh screen with all the sovereign apps that you have installed. The LED has changed to tell you that the display has switched to the sovereign domain. The user unsurprisingly selects the chat app. It loads the history securely from the storage, and the user starts texting with Bob. Messages go over the network on a secure channel. Alice receives messages. She can continue typing whatever she wants. At this point, only the sovereign world has access to the display, the input and output. Right? So the operating system has no idea what's happening. And after that, the user can switch back to the legacy OS. Okay. Now you might wonder, is this all for just chat apps? Well, no. We have multiple use cases that we have developed, including a secure browser, a VPN, and a few interesting use cases for other stakeholders, such as the manufacturer and the operating system. If you're interested in the technical details, our archive version has all of it and more. So please go check it out, and happy to take questions if we have time. Thank you.
Do we have questions?
Hi, Shweta. So typically with these TEs, they have this attestation feature, and if we keep swapping from one app to the other, what's that overhead and things like that?
Yeah, so there are two stages where you need attestation. One is when you load the security monitor or the firmware, you have to make sure it's the right firmware and not corrupted. That already exists on your phones. In fact, as a user, you can't change the firmware. So that part is taken care of. Now, when you launch the sovereign domain or apps for the first time on your phone after booting up, that's when you have to do the attestation. And because you trust the security monitor, it can help you do the attestation for you, right? So very similar to how it would work on, let's say, SGX. Of course, the manufacturer has to put a key in there and support the whole machinery behind the scenes for attestation, but that kind of works out of the box. Now, during execution, you don't need attestation. When you're switching, the data stays in the memory, the monitor just protects it using hardware. Right? So during execution, you don't need any attestation. All right?
I just want a quick clarification. You were mentioning the contact tracing app, Apple, and is not allowing things.
Yeah.
So how will this change? So don't you need Apple to put that button on there, or the software? How would that work? Thank you.
Yeah, so you're right. I mean, I can go build this phone and no one will use it because it's not an Apple or a Google phone. So you're right. There are actually a few things. One is the physical button that you saw. The other is the firmware has to be updated, right? So the manufacturer has to agree to support this. The big difference you might observe is that once Apple or Google puts this in the firmware, from there onwards, access to peripherals is independent. I don't have to go and talk to Apple every time I want to create a new app which accesses Bluetooth or Wi-Fi and so on, right? So this is a one-time change which Apple or Google has to agree to, and after that, your sovereign apps can directly access peripherals, right? Because they're no longer in control of what you can do. So that simplifies the problem. Of course, the first time they can refuse, right? But at least now there is a technical solution where we can argue saying, hey, this is not impacting your security and privacy. Because right now, the reason they give us is, well, you're writing some random contact tracing app. If I let you run that, it might attack all the services Apple and Google are running. So at least this isolation leaves them with very little technical reasons to not do this.
So these Apple phones have secret keys in some of their peripherals, right?
Yes.
So like the Apple Secure Enclave assumes that there's these shared secret keys.
Yeah.
So I was just wondering if you're swapping these things in and out, I mean, does that impact you in any way? Or?
Yeah, so that's a good question. So if you, and again, I don't know the details because Apple doesn't share details, but yes, Apple has a secure enclave. In fact, it's a separate chip on your phone which holds the biometric data, and they only expose a very limited interface which iOS could use to check whether the biometric thing passes or not. I would say our solution is complementary to that. If they adopt this, they may not need a special hardware chip to hold the biometric data because now you can achieve it via hardware isolation. But I don't think they conflict. All right.
Great, thank you. Let's thank our speaker again.